Hello ladies and gentlemen, today this is Pre-Calc Lesson 78, the hyperbola. So let's first start with some review of our ellipse, our good old friend the ellipse. We should be pros at graphing the ellipse by now. Remember, your graph just has to be as pretty as mine. Okay, we know that the standard form is x squared over a squared plus y squared over b squared equals 1. And we have our foci, f1, f2. And we said if this was d1 and this was d2, d1 plus d2 equals a constant. Okay, quick little review of our ellipse. Now we review our ellipse because the hyperbola is very, very, very similar. Okay? So, the hyperbola, please don't say hyperbola, it's hyperbola. Okay? Our definition is the locus of all points such that, remember our new symbol, such that, the absolute value of the difference of the distances from any point on the hyperbola to two fixed points, our foci, is a constant. The locus of all points such that the absolute value of the difference of the distances from any point on the hyperbola to two fixed points is a constant, meaning the absolute value of distance 1 minus distance 2 is a constant. And these two fixed points are still our foci. Okay. Now, the hyperbola has two curves. Okay, so if I graph this, I'm going to have my one foci, my other foci, and the hyperbola has two curves facing away from each other, similar to a parabola where it's pointing towards its focus. Okay, this point and this point, if I bring them down here, we have negative a0 and a0. They are exact mirrors of each other. And what this whole thing is saying, that if I had a point on my hyperbola, and this was distance 1, distance 2, the absolute value of d1 minus d2 is a constant. And the formula for my equation of a hyperbola is x squared over a squared minus y squared over b squared equals 1. The minus is the key. Okay? Now, this is when we have our foci on the x-axis. We can also have our foci on the y-axis like this. And then this point is 0a, 0 minus a. And it changes. We have y squared over a squared minus x squared over b squared equals 1. In this case, the order does matter. Okay, if y squared is first, then that means the foci are on the y-axis. Okay, now, every single hyperbola has asymptotes, specifically 2 of them. Okay, now what is an asymptote? An asymptote is a straight line. The graph approaches but never crosses, or never reaches. Okay? It gets really, 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 really close, but it does not cross it. Okay? So I'm going to show you an example for all the things and to find our two asymptotes. Okay, we want to sketch this graph and find the equation of our asymptotes. So if we have x squared over 9 minus y squared over 4 equals 1. Okay, x squared is first, which means that our foci are on the x-axis. And we have a squared is 9, so a is plus or minus 3. So on my graph, I have this is 1a. That's my other. Okay. And I know that my graph is going to look like the first graph I showed you. Okay. And we see this is true, right? We have the points negative 3, 0, and 3, 0. If we were to plug in 0 for y, that is what we would get for x. Okay. Now, what if I plugged in 0 for x? Okay. Let's do that. So 0 squared over 9 minus y squared over 4 equals 1. So I have this term becomes 0. Okay. I have minus y squared over 4 equals 1. So minus y squared equals 4. Y squared equals negative 4, which means y is plus or minus 2i. Now the 2i, these are my vertices, okay, of my parabola. So what does that mean? If I was to graph 0, 2, and 0, negative 2, I have this box that is created, okay, and in the box I have the diagonals of this box. And the diagonals show me the shape of my hyperbola. See how my hyperbola comes close, but these diagonals almost curve my hyperbola away? Yes? Now, this is really, really important because this is how we get our asymptotes. Okay? We look at these corner boxes right there, or I'm sorry, the corners of the boxes, and I find that this point is 3, 2, this is negative 3, 2, which tells me that those are the 2 points I can use to find my asymptotes. I have 2 of them. Okay, now they should go through the origin. So for one of them, it goes through the origin and 3, 2, which we can find that slope, y equals the change in y over the change in x. And it goes through 0, 0, which means my b is 0. So that's one of my asymptotes. My other asymptote goes through the point 0, 0 and negative 3, 2, which if I do the same thing, I have negative 2 over 3x. Again, it goes through the origin, so my y-intercept is 0. And those are my 2 asymptotes. You see how the asymptotes are directing the shape of my hyperbola. And vice versa, this asymptote is directing the shape of the hyperbola here. It really does help to draw that box. Okay? Let's do another example. Make it even more clear. So we're going to sketch this graph. We have y over 4 minus x squared over 25 is 1. Okay. I first want to solve for a, meaning I plug in 0 for x to solve for a. We know that our foci will be on the y-axis. Okay. And I know that a squared is 4, so a is plus or minus 2. So I will have 0, 2, and 0, negative 2 on my graph. Let's do that. Okay. Then I also need to plug in 0 for y and solve for my x to be able to find my asymptotes. So I will get negative x squared over 25 is 1. So x squared is negative 25. X is plus or minus 5i. Okay? So we put on the x-axis, it's 5, negative 5. Draw our box. And notice that I have corners on 5, 2, negative 5, 2, where my asymptotes will go through. That asymptote was a little curved. Okay, and my graph will go oops. This is not the graph. This is, I got a little too excited. Not that one. Because remember, y squared is first. So we are on the y-axis, not x squared. Okay, and I know one of my asymptotes goes through 5, 2, and 0, 0. So y equals, our slope is the change in y over the change in x, which will be 2/5. And we know that we have the exact negative of that as well, negative 2/5. Those are my two asymptotes. Okay. Now let's do a slightly harder one. I think I'll have room on this page. What if we started with 4y squared minus 9x squared minus 36 equals 0? We have to first put it in standard form. So move the 36 over, so 4y squared minus 9x squared is 36. And then I'm going to divide every term by 36. Okay, leaving me with y squared over 9 minus x squared over 4 equals 1. Okay, this is the standard form. And I know from here that y is going to be plus or minus 3, x is going to be plus or minus 2i, and y is first, so that means my parabola is going to be facing up. 1, 2, 3, 1, 2, 3, 1, 2. Notice how I'm labeling things and drawing my box. That was not very straight. Box is helpful to be able to draw your asymptotes. And I know my graph is on the y-axis, so we're up here. Okay? And I have these corner points, which I know will be 2, 3. That's one asymptote, and negative 2, 3. That's my other asymptote, which tells me that y is going to be 3/2 x, and y is going to be negative 3/2 x. Those are my two asymptotes. Okay? Again, if you have any questions, make sure that you bring them to class tomorrow, because that is all for today.